Hello everyone and welcome to the lecture on Amazon Managed Service for Apache Flink. This service was previously known as Amazon Kinesis Data Analytics or Amazon Kinesis Data Analytics for Apache Flink. So you can see in the documentation or in the exam questions, the service may mentioned as Kinesis Data Analytics or Kinesis Data Analytics for Apache Flink. But right now all the documentation has been updated with Amazon Managed Service for Apache Flink. So this lecture will contain all these topics. What is Amazon Managed Service for Apache Flink? Apache Flink versus Apache Flink Studio. Apache Flink APIs, how it works. Connectors, which includes your sources, and sinks, which are basically destinations. Using Kinesis data streams. Creating a Kafka source. Transform data using operators. List of operators. Using transform operator example and using aggregation operators example. So what is Amazon Managed Service for Apache Flink? Apache Flink is a framework and engine designed for processing data streams. It is used to create solutions for time series analytics, real-time dashboards, and generating metrics. It is an open source tool and it offers libraries compatible with Java, Scala, Python, and SQL. Its core programming features include operators, functions, sources, and sinks used for advanced data manipulation. The service manages the underlying infrastructure, including provisioning resources, ensuring availability zone failover, resilience, enabling parallel computation, automatic scaling, and handling application backups. The service lets you build applications using open source libraries based on the popular Apache Flink framework and the engine. Apache Flink versus Apache Flink Studio. So there are two versions. One is Apache Flink, which is over here. So basically you develop the Flink application directly, and then there is a Studio version in which you have two options. You can use Scala, Python, and SQL. And there are two choices, like you can run deploy the application directly over there, or you can have a studio application. So I'll just briefly discuss like what is the difference and which one you choose when you have the choice. So Amazon Managed Service for Apache Flink offers two options as I talked about. One is Managed Service for Apache Flink and the Managed Service for Apache Flink Studio. Managed Service for Apache Flink allows building applications in Java, Scala, or Python using an IDE of your choice with Apache Flink data stream or table APIs. Managed Service for Apache Flink Studio enables interactive querying of data streams in real time and building applications using same SQL, Python, and Scala. Your specific use case should determine which options to choose. Managed Service for Apache Flink is ideal for long-running applications like streaming ETL, extract, transform, load, or continuous applications. This allows integrations with software development lifecycle processes. Managed Service for Apache Flink Studio, now we are talking about Studio, is better suited for ad hoc data exploration, interactive streaming data queries, or creating real-time dashboards. Users familiar with SQL can deploy long-running applications directly from Studio. So from Studio, you can deploy the SQL-based application. Apache Flink APIs. So Flink provides 4 levels of API abstractions. First one, Flink SQL. Next, Table API, Data Stream API, and Process Function, which is used with Data Stream API, all of which are supported in Amazon Managed Service for Apache Flink. It is recommended to start with higher level abstraction levels when possible, though some features are only available with the Data Stream API, which supports Java, Python, and Scala. Consider using the Data Stream API when you need fine-grained control over the state management. The Data Stream API is recommended for asynchronously calling external databases or endpoints, such as for inference operations. Use Data Stream API when custom timers are needed for implementing specialized windowing or handling late events. Data Stream API allows modification of application flow without resetting the state, providing greater flexibility. So how it works? Apache Flink applications are Java or Scala applications created with Apache Flink framework. Then primary APIs. So applications primarily use either the data stream API or the table API, though other Apache Flink APIs are also available as I talked about. The data stream API programming model is based on data streams, which are structured representations of continuous data flow. So this is important. And transformation operators, which are basically processing components that transform input streams. So you have structured continuous data flow coming in, and then you have operators which will transform the input stream. Data stream API applications read data from a data source, apply transformations to the data, and write transform data to a data sink. Data stream API applications can be written in Java or Scala and can read from Kinesis data streams, Amazon managed service for Kafka, MSK topics, or any custom sources. Apache Flink uses three types of connectors: source connectors, which will read from external data, sink connectors, which will write to external locations, and operator connectors, which are used for processing data within the application. The table API programming model consists of table environment, interface to underlying data, next tables, which are objects providing access to SQL table and views, table sources, which are reading from external sources, and table functions, which are basically transforming data. And lastly, we have table sinks, which refers to writing to external locations. The table API applications create a table environment, create tables using SQL queries or API functions, run queries on tables, apply transformations on query results, and write results to a table sink. The table API applications can be written in Java or Scala and can query data using either API calls or SQL queries. So these are the connectors. This includes both sources and the sinks, which are destinations. So these are Apache Kafka, which can be both a source or the target, Apache Cassandra, which can only be a target, Amazon DynamoDB, which can only be a sink or the target, Amazon Kinesis data streams, which can act both as a source and a sink, Amazon Kinesis data firehose, which can only act as a sink, Elasticsearch only sink, file system can only act as a sink, RabbitMQ, which can act both as source and a sink, Google PubSub, which can act both as a source and a sink. Then we have hybrid source, which can act only as a source. Then we have Apache NiFi, which can act both as a source and a sink, Apache Pulsar, which can only act as a source, and JDBC, which can only act as a sink. So using Kinesis data stream, this is an example code. So this is acting as a source, and from Kinesis data stream, this will integrate with our Apache Flink managed service. So first we are setting the initial position for consuming the Kinesis stream to trim horizon, which means that the consumer will start reading from the oldest record in the stream. This is optional, and if not specified, the default latest, which means reading only new records that arrive after the consumer starts. Second, this particular line. So here we just initialize the builder pattern for creating a Kinesis stream source with a generic type parameter of string, and this indicates that the records will be deserialized into string objects. Next, this particular line, we are just specifying the ARN, which includes all AWS region, account name, stream name. Then fourth, we apply the configuration settings defined earlier to Kinesis stream source, which includes the initial positions setting. So here, then fifth is this particular line. We are setting the deserialization schema to simple string schema, which will convert the raw Kinesis records into string records. Different schemas can be used depending on the data format. Sixth, we configure the shard assigner strategy that determines how Kinesis shards are distributed among parallel subtasks. The uniform shard assigner distributes shards evenly. So this particular thing. This setting is optional and defaults to uniform assignment if not specified. Finally, we do a build. So finalize the builder pattern and create the Kinesis stream source instance with all the configured settings. So here, this is a different example how to use a Kafka source. So first, this particular line specifies the Kafka broker addresses to connect to using the brokers variable, which should contain a comma separated list of host and port pairs. Next, here we are defining the Kafka topic to consume messages from. In this case, it's input topic. Then we set the consumer group ID to my group, which is used by Kafka to track the consumption progress. Fourth, we configure the consumer to start reading from the earliest available offset in the topic, ensuring no messages are missed. Fifth, we specify a deserializer that processes only the value portion of Kafka records and converts them to string objects. Sixth, we add the configured Kafka source to the Flink execution environment with no watermark strategy for event time processing and assigns the name Kafka source for monitoring and visualization. Next, transform data using operators. So operators is an important concept. So you can Apache Flink operators are essential components in the managed service for Apache Flink that transform the data streams. They convert one or more data streams into a new data stream, effectively producing modified data from the original sources. The managed service for Apache Flink provides users with access to more than 25 pre-built stream processing operators, offering a comprehensive toolkit for various data transformation needs. So here I'll just talk about 10 very popular operators. So first one is map. It takes one element and produces one element. Then we have flat map. It takes one element and produces 0, 1 or more elements. Filter operator. It evaluates a Boolean condition for each element and retains those for which the function returns true. Then we have key by operator. It logically partitions a stream into disjoint partitions. All records with the same key are assigned to the same partition. Then we have reduce operator. This is a rolling reduce on a keyed data stream. It combines the current element with the last reduced value and emits the new value. Window operator. It groups data in each key according to some characteristics. For example, data that arrived within the last 5 seconds on already partitioned keyed streams. Window all. It groups all stream events according to some characteristics. For example, data that arrived within the last 5 seconds on regular data streams, often a non-parallel transformation. Then window apply. This applies a general function to the window as a whole. Window reduce. This applies a functional reduce function to the window and returns the reduced value. And then union operator. This merges two or more data streams, creating a new stream containing all elements from all input streams. So this example shows how to use a transform operator. So in this particular code, here we are creating a new transform data stream by applying a map operation to the input stream, which contains a object node elements. Second, this instantiates an anonymous class implementing the map function interface, specifying both input and output type as object node. Third, this implements the required map. So this particular function map method that will be applied to each element in the input stream. And lastly, this is an important one. This modifies the incoming object node by appending company. So there is a space company to the value of the ticker. So this is a stock ticker field and returns the modified node. So this is a simple example, but just it illustrates how to use the transform operator. This one is an aggregation operator. So this this partitions the input data stream by the value of ticker field, ensuring that all records with the same ticker symbol are processed by the same parallel task. So because we are doing some aggregation, so we are first grouping them by the symbol, the stock ticker symbol. Next, this applies a tumbling window of 5 seconds in processing time. So here this particular line, grouping records that arrive within the same 5-second interval. Third one, we are defines a reduce function that will be applied to all records within each window for each key. And this particular line, fourth, this calculates the sum of the price values from two object node records by extracting the double values. And this particular fifth updates the first node by replacing its price field with the newly calculated total using JSON node factory to create a new number node. So basically it is summing, it is reducing and adding the sum. So it will take the current value and the next record value, and we'll just keep adding, summing them. And finally, once it has done the reduce, the whole thing reduced, then at 6, it will return the modified first node as the result of the reduction, accumulating values as the reducer processes more elements in the window. So similar to map reduce, so you have a map function or the reduce function, so it will just add all the values and return the sum based on the ticker symbol, grouped by the ticker symbol. And that's all. Thanks for watching.